Hey guys, welcome back. It's Danny with Partner Engineering, and welcome to tutorial 2 of the cloud migration journey, where we are working through how to leverage Kong products, both Konnect and Mesh, to support our migration journey. Now, just to recap, what we did was in the first tutorials, we introduced the phased migration approach, crawl, walk, run. And then we executed the crawl phase, where we introduced Konnect to a simulated on-premise environment. So in this phase, we've got our on-premise environment. It happens to be running in AWS just for practice. And what we did was we deployed a Konnect runtime instance. It's also referred to as a data plane. It can also be referred to as a gateway. Once we had that VM deployed, we went into Konnect and we configured Konnect to expose our monolith service. Once that configuration was done, we went into Insomnia and validated that API client could reach all of the services that the monolith supported. Now, in this tutorial, we're going to move on to phase 2, walk. In this phase, we're going to be introducing Kong Mesh and understanding how we can use its universal deployment strategy alongside its Kubernetes deployment strategy to build out a networking infrastructure that spans our on-premise and our cloud. So with that, let's go ahead and get to it. Okay, so if you're following along, let's go back to the Git repository and we're going to navigate to step 6, phase 2. Copy this make command and then go ahead and in your terminal, execute it. While this is running, let's go ahead and navigate into the Explore README and see what we're doing. So in this phase, we're doing a few things. We're installing the Kong Mesh global control plane. And after that is in place, we're preparing the Kong Mesh on-premise zone. This is where we're going to be learning how to take advantage of Kong Mesh's universal mode deployment strategy. Once the zone has been set up, we're then going to the last step of the mesh will be deploying the mesh data planes so that each service that we want to be a part of the mesh, so both the monolith and the runtime instance, we want to be a part of the mesh, each have an Envoy sidecar. From an infrastructure perspective, this is what it looks like. So we've got Kuma running or Kong Mesh control plane running up in an EC2 instance. And then in the simulated on-premise zone, we've got within the VM where our Konnect runtime instance is deployed, we've got 3 additional services: the zone control plane for Mesh, the Kuma egress, and ingress services running. The zone control plane is responsible for communicating with the global and then propagating out instructions to the data planes. The egress and ingress are used for multi-cross-zone communication. So in this phase, we're just taking advantage of our on-premise zone that's running. We're just leveraging that on-premise zone. But in the last tutorial where we introduce the cloud and do the cutover, the cross-zone communication actually is going to be happening through this ingress and egress processes we have running. Once the zone services are properly stood up, the last step we said was deploying a Envoy sidecar to any microservice or service we wanted to be a part of the mesh. So from the architecture diagram, the monolith is provisioned a sidecar and the runtime instances provision a sidecar. Once all of this infrastructure is set up, we then need to go into Konnect and reconfigure it so that communication happens over the mesh. And then once we've completed that configuration, we can go ahead and validate. We'll go back into Insomnia, we'll make some API calls and make sure that we can still reach our monolith service. So it's going to take a few minutes to finish the deployment, so we'll be back in a second. So the playbook is done running, so we're going to go ahead and move to the step where we're going to explore the infrastructure a little. The first thing we're going to do is just review the global control plane from the GUI. So if you're following along with the tutorial, within the demo facts, you need to grab the global CP URL. Okay, so from the home page, there's a lot of interesting information. From the top right-hand corner, you can see the version of Mesh that you're running. So we are on latest right now. Universal means the deployment strategy for the global CP. So universal is the VM-flavored deployment strategy. And then multi-zone, meaning we have 2 options for the zoning. We can do standalone, meaning the mesh is expecting all resources to be an independent deployment strategy. Often we do this with Kubernetes. And then the other is multi-zone, where we can have different various types of zones. In our case, we're going to have an on-premise zone and a cloud zone. You could have 2 cloud zones. You can have X number of cloud zones, X number of on-premise zones, all communicating with each other. Within here, we can see the number of data planes deployed, how many licenses we've used up. So we can still deploy 4 more data planes. We can see the number of zones, meshes, services, Envoy version. On the top left, let's review through the zones. So we can see we have one zone, it's called on-premise. The storage type is Postgres. Within this zone, we can see, let's check out what ingress and egress is. We've got 1 ingress for on-premise and 1 egress for the on-premise zone as well. Now let's move to the mesh. We can have multiple meshes deployed with Kong Mesh. Right now, we're just going to be leveraging the default mesh that spins up with the infrastructure. If we go to the overview page, in the overview page, what's really convenient is you can just see that the NTLS state of the mesh. So right now it's disabled. We do need to enable that, and we'll be doing that during this tutorial. Next, with services, we can see all the types of services that we have deployed on the mesh in the services tab. So the first one, Kong, is of type gateway delegated. This means that this service is going to allow north-south traffic into the mesh network, which is what we want a gateway for. The second one is internal, and this is for the monolith service, meaning that this service we do have east-west traffic happening, but no north-south, right? That's all that north-south is being delegated to the gateway. And if you needed to, you could break this down further. So gateways would list all of your gateways, and then data planes would list all of your internal services. So that's the GUI. Let's move back to GitHub, and let's keep going. We're gonna skip some of these validation steps because you can repeat them on your own if you're following along, but I do wanna go through the on-premise zone control plane setup. The main thing I wanna highlight is with Kong Mesh, again, we have the concept of universal mode deployment strategy. It's another way of saying it's how our documentation states that we deploy onto VMs. And what does that look like? So we're just going to SSH in and take a look. For this on-premise zone CP, I want you to grab from your demo fax the SSH command that's SSH runtime-instance, because that's where the services are running. And we're going to navigate back to our terminal. SSH in there. I'm just going to clean up the screen. And then we are going to just systemctl out the status. So what we've done, the most important thing to realize is that all of these services, they're just binaries that we downloaded, and then we just started systemd processes for all of them. And the information that they know, it's pretty rudimentary. They need to know where the global control plane is. They need to know, the data planes need to know where the zone is. Same with the ingress and egress. So that's the one thing I wanted to highlight there. Okay, next, let's go ahead and move through. Go ahead and cover zone ingress and egress independently, but I do want to pause and talk about the data planes because we have 2 types. We've got the gateway delegated type, and then we have the standard internal type. So first, we're going to start with what we're using for the gateway. I want you to go ahead and SSH. Actually, we're already in the runtime instance that we need, right? So let's go ahead and cat open the manifest file for the data plane. Now, one thing is for these manifest file, I didn't say this before, but because we're in universal mode, we are responsible for writing all of the manifests. But if you are in Kubernetes, which we'll see in tutorial 3, all of this work is done for us, right? But with the VM flavor, there is a little bit of legwork we got to do. We don't have that luxury of Kubernetes. Okay, so let's take a look at this data plane manifest. First, let's highlight the first 2 lines is, it's of type data plane. Second line highlights what mesh it's associated with. Name, so this is going to be the name of the resource as we see in Kong Mesh. Let's go back to our data planes. Gateway. And we can see the same manifest here. It's got name Kong. The address, this is where the data plane, the Envoy proxy data plane is going to be reachable at, the IP address or host that it's reachable at. And then some information here about the gateway. So it's type delegated. There are 2 types of gateways that we support with Kong Mesh. We've got delegated, i.e. you bring your own, or there's built-in. So we could have run a built-in and spun it up. But here we really want to learn how to take advantage of Konnect and Kong Mesh together, so we're using the delegated gateway. Then the tag, so this is the tag used to represent the Kong gateway. Again, it's just service Kong. So if any other services within the mesh needed to reach this microservice, the gateway microservice, they could use this tag to do so, or they could use this service name to do so. And then outbound. So with universal mode, there's two deployment strategies here within this. There's transparent proxy and non-transparent proxy. We are using non-transparent proxy for simplicity, but because of that, we needed to find this outbound port section. So any traffic leaving the gateway, we're not going to be using the service name to locate that service. We're actually going to be going out the outbound port, localhost outbound port. So for anything we want to drive towards the monolith, we need to define outbound port 33033. And with any traffic that needs to go outbound to the microservice, it's going to go out 33034. And we'll see how we're going to take advantage of this. We're going to have to use this in a little bit when we actually go to the configuration step of this tutorial. Okay, and then the last is we're just going to look at the manifest for the monolith from the browser. So if we're looking at this section right here, the manifest for the monolith data plane looks very similar. So it's still of type data plane. We define the mesh. We've given it a name. We know the IP where this service is reachable at, but it's got an inbound section that we have to write. So it's exposing the proxy, Envoy proxy on port 5000, that's the port it's going to be available on, and the backend service that it's supporting, the monolith, is exposed on port 8080. And then again, we've defined a tag for it. And the tag's important because as we see for our non-transparent proxy, we're saying use this tag. Anything designated for the monolith is going out port 33033. So that's the quick overview of the infrastructure. There's more information within the tutorial, so please feel free to take a deep dive, SSH into all of the boxes that's there in your demo facts, and to review everything that's going on. But right now we've given you a pretty good surface level overview. Okay, so let's actually move into the configuration, the actual activities of the tutorial. So if you're following along, we're going to scroll down to the activities. And the first thing we're going to do is enable MTLS. It is important to understand that for cross-zone communication to be successful, we do need to have MTLS enabled. I have a tendency of forgetting to do this in phase 3, so we're going to do it phase 2. Because we're working with the global control plane for Kong Mesh and universal mode, we actually need any activities, any configurations we push, traffic policies that we expect the mesh to manage, we need to actually execute on the box itself. So we're going to SSH into the Kong Mesh global control plane for this step. In order to do that, just go into your demo facts and grab the fact that says SSH global CP. If you haven't already, go ahead and log out from the VM that you're in, SSH back in, fresh. Just going to bring the screen up and then copy this command. Actually, I'm pretty sure this command is slightly wrong, so we're going to clean this up a little bit. I want you to just clean up the path to be mesh instead of / default, just do mesh.yaml. We're going to apply that. We worked without an error, so that means that it was successful. And we can validate this, so we're just going to go over to the mesh, to a TLS report, and we can see that we've got our default mesh has MTLS enabled, so it worked. That's good. Now we need to do some reconfiguration with Konnect, and that is because the objective of this tutorial again is to deploy the mesh and then onboard the monolith and the gateway so that traffic flows over the mesh network, right? So we need to tweak it a little. So what we're going to do is let's go ahead and log into Konnect. Make sure you're in the correct runtime group. So I'm in default. And we're going to make a new gateway service. I'm going to call this service mesh. And I'm actually just going to toggle this radio button, add using protocol, host, port, and path. Leave it on HTTP. The host is going to be mesh, or it's going to be localhost. The port is going to be the outbound port for the monolith, which we said was 33033. 33033. The path, because we're still This is the base URL of that the monolith exposes. It's still going to be /monolith resources. This looks ready, so go ahead and save. Next, we need to create a route. So from this gateway service, go to the routes tab, select the add route button. Call this mesh again. We're just gonna, for the protocol, just stick with HTTP. The path needs to be very specific. So let's go check the docs real quick. Create a route mesh HTTP protocol will expose the get method path/meth. I'm gonna copy that, go back to connect, paste the slash mesh into the paths. I'm gonna add a new rule, methods, get. Go ahead and save this. Okay, so now the mesh, or now the gateway service, we created a new gateway service, and that network call should go over the mesh network rather than the traditional network that we have. And just so that we can see, just for playing purposes, we left the migration one, so where the communication is not occurring over Envoy, so that you guys could just visually see the difference. Now from here, we're going to go back into Insomnia and go ahead and make sure that communication is still working from an API client. Let's go back to Insomnia. I want you to open up the phase 2-3 folder, and we're going to go ahead and make all of these API requests here. So from card, let's go ahead and send. Need to grab my runtime-instance IP, paste that in, submit. Okay, perfect. It's working. Let's do the rest. This is payments is working. Balance is working. Charges working. And last, disputes. Yep, still same response. Please dial in to see disputes on file. Okay, perfect. So we are officially ready to go. So let's just review what we've done. Let's do an overview of the infrastructure. So in this walk phase, we really focused on mesh. We installed the Kong Mesh global control plane, and then we focused on building out this zone on the left-hand side, our on-premise zone. Within this zone, we logged in, or we SSH'd the VM, and we took a look at the universal zone services. The 3 services for the universal mode was the zone control plane, the zone, the Kuma egress and ingress services that are going to allow cross-zone communication. And then last, for any service that we wanted onboarded to the mesh, they were provisioned as Envoy sidecar. So our gateway was provisioned a sidecar, and our monolith was provisioned a sidecar. Once that infrastructure was set up, we reconfigured Konnect so that communication happened over the mesh network, and then did the validation with Insomnia. So that was phase 2 of our crawl, walk, run migration strategy. In the next tutorial run, we're actually going to get our cloud zone set up and then go ahead and execute the final cutover. I hope you guys enjoy this tutorial, and I will see you all over there.